Hello everyone. Today in this session we are going to discuss about time domain and frequency domain and digital representation of information. First we'll see time domain and frequency domain. A sine wave is defined by its amplitude, frequency and phase. In the example, a sine wave shown in the time domain plot, the time domain plot shows changes in signal amplitude with respect to its time. As you see in the diagram, in the time domain, the signal amplitude is changes according to the time. The phase and frequency are not explicitly measured on time domain point. Whereas in the to show the relationship between the three characteristics amplitude, frequency and the phase, we use frequency domain. As you see in the diagram, a frequency domain is concerned with only the peak value of and the frequency. There are two types of frequency domains are there: maximum amplitude versus frequency, phase versus frequency. This diagram compares the time domain and the frequency domain. Time domain is nothing but instantaneous amplitude with respect to the time. Frequency domain is nothing but the maximum amplitude with respect to the frequency. Digital representation of information. Applications that run over the internet works involves the transfer of the information of various types. Some of them may involve blocks of texts like email and other involved stream of information such as telephony. So here block oriented information, the information can be classified into two broad categories. One is block oriented information and stream information. First we'll see what is block oriented information. Block oriented information occurs naturally in the form of a single block. These blocks of information may range from a few bytes to several hundred kilobytes and occasionally several megabytes also. Normal files of these forms usually contain fair amount of redundancies, like letter E is repeated several times in a text. Hence, data compression utilities such as compress, zip and other methods are used to encode the original information into blocks, which will now take fewer bits to transfer and less disk storage space. Example, data files Example data files, block and white documents and pictures. This is about block oriented information. Next, stream information. The stream information is produced continuously and must be transmitted as it is produced. How it is produced? It is transmitted in the same way. These signals are analog signals that are digitalized before transmission. The first step in digitalizing an analog signal is to obtain sample values of the signal every t seconds. The second step in quantizing each of the sample values. The last step is to convert them into digital signals. Video signals are succession of pictures that gives illusion to the human eye that appearance of the continuous motion. For example, voice and music. This is about stream information. In this session, we have discussed time domain and frequency domain, digital representation of the information, that is how is the time domain and how is the frequency domain, and how the digital representation of the information is represented. That can be classified as two types: block oriented information and the stream oriented information. Block oriented information occurs naturally in the form of a single block, but in the stream information it is produced continuously and must be transmitted as it is produced. This is about this session. Thank you.